Welcome to day 2 of our quadrilateral unit. In our planners, we can be writing either day 2 or packet page 9 and 10. We do have a warm-up for you to try. Notice all the things that are marked up in our parallelogram there are angles. So you want to be thinking of your angles reasons from your card to help you set up some equations to solve for each of those variables. Also, you want to have your homework out turned to the day 1 assignment. So after we go over the warm-up, you'll be ready to go through that. We're going to pause the video for 4 minutes to give you a chance to do the warm-up and make sure you find all 3 values, x, y, and z. So we had a set of opposite angles there that only had x's. So we wanted to start with the fact that 2x plus 12 is equal to 3x minus 18. Notice that only has x as the variable, so we can go ahead and solve that. I'm going to subtract the 2x over to give us 12 equals x minus 18. Add the 18 over to give us 30 equals x. So that's part of what we needed to know. Well, if we sub that 30 back in, 2 times 30 plus 12, that would give us 60 plus 12, or in other words, 72. And this would be the same here because opposite angles are congruent. Well, now that we have the 72, now we can set up some equations using the fact that consecutive angles are supplementary. So the 4y and either of the 72s are consecutive, so we can say 4y plus 72 should equal 180. We'll subtract the 72 over. So 4y will equal 108. And we'll divide by 4 to get that y is 27. And we can do same idea for the 3z. We can do 3z plus 72 equals 180. Subtract the 72 over, we get 3z equals 108. And divide by 3 to get that z is 36. So if you see with parallelograms, you've got angles. The only things you should really be looking for are either opposite angles congruent or consecutive angles supplementary. You can stick your warm-ups away. We'll flip over to homework. First question gave us something for BE and for DE. Those are parts of diagonals. The only diagonal reason we have is diagonals bisect each other. Well, segment bisector implies midpoint. Midpoint implies 2 congruent segments. So these should be congruent. We'd actually get those congruent as well, but we don't need them. If they're congruent, we should be setting them equal. When you set these equal, we get x equals 15. And then they wanted to know what BD is equal to. There's 2 ways you can figure out what BD is. You can either sub it into both of them added together. So you could have done 6 times 15 plus 1 plus 4 times 15 plus 31, which I'm guessing most people did, and you'd get 182 for BD. Or, because we know DE and BE should be equal, what I did is I just subbed into BE and then doubled it to get the 182. In B, we've got AE, an expression for is x plus 1. And then the whole thing, AC, is 5x minus 10. Well, once you've labeled all expressions they tell you in the problem, if you know any things are equal in your picture, and you only have one of them labeled, you can label the other ones that same expression. So what I mean by that is, because the diagonals bisect each other, we know AE and EC should be equal. AE is labeled with an expression, EC is not. So you would go ahead and label EC with AE's expression. You don't want to do that until you have labeled everything in the question, because sometimes they might give you an expression for EC. From there, we can use our idea that part plus a part equals a whole. So you can either do x plus 1 plus x plus 1 equals 5x minus 10, or I chose to just do it as 2 times x plus 1 equals 5x plus 10. Either way, you would eventually get x equals 4. And then we want to find EC, which is just x plus 1. So when you fill that in, you get EC as 5. Going on to number 2, this is like one we saw in class. Draw a picture of a parallelogram. Start A wherever you'd like. Then go around in a circle, either clockwise or counterclockwise, labeling your B, C, D. Then wherever your A and B ended up, put in our 2x and 7x, because when we have a ratio, we just want to put a variable after each of those numbers. Consecutive angles are what we have there. They're supplementary, so add them, set them equal to 180, you get x is 20. And we want to find angle A, so you just sub the 20 back in to get 40. And 3, had to draw your picture again. Again, start A anywhere you want. Go around in a circle as you label the other letters. We ended up with opposite angles, which are equal. Set them equal and solve. You eventually got x is 5. They wanted both A and C, so we had to sub the 5 back in, and we got 31 degrees for both of those. Going over to the next one, we had to draw the picture again. Start A where you want, circle around to label the other letters. Label all 4 of your expressions. Notice we have opposite sides. We want to work with the fact that opposite sides are congruent. So there's 2 equations we can set up. The y plus 4 equals 2x plus y. The 4x plus y equals 3x plus 6. At this moment, it looks like we're headed towards elimination. But in that left-hand equation, when you subtract y, notice the y's go away. So that turns into something we can just solve for x, and we get the x equals 2. So because we now know x, just fill it in the other equation, and we'll be left with something we can solve for y. We get y equals 4. And then we wanted to find all the lengths of the sides in the parallelogram, so sub them back in. We ended up getting 12 for A, B, and C, D, and 8 for B, C, and AD. For 5, picture was drawn for us. AD and BC were opposite sides. We know parallelogram implies opposite sides congruent, which means they should be equal. Set them equal and solve. We just had to find x. We got 14. And 6 was like one we did in class. We had 2 consecutive sides. By the fact that parallelogram implies opposite sides congruent, we can now label this x minus 2 and this 3x plus 1. Either add up all 4 sides, or what I showed is I just doubled each of them, because there's 2 that are the same, and then that should equal what they told us the entire perimeter was, 10x minus 32. And when you go through and solve, we get that x is 15. All right, we're going to be working on our parallelogram proofs today. So the first thing I want you to do is take out your study card, fold back the 5 parallelogram reasons, and we're going to pause the video for 5 minutes for you to either quiz yourself, or you can, within your group, quiz each other. So just to be clear how we're reading these, notice the arrow for the implies is over on the left. So we have parallelogram implies opposite sides congruent. Parallelogram implies opposite sides parallel. Parallelogram implies opposite angles congruent. Parallelogram implies diagonals bisect each other. And we won't see this last one much in proofs. We use the last one mostly in algebraic problems, but we have parallelogram implies consecutive angles supplementary. So we're going to pause the video for 5 minutes right now. The goal is at the end of 5 minutes for everyone to have those 5 memorized if you don't have them memorized already. If you find that you're able to go through and do them all, then put your energy into helping your group mates and quiz them to study where they can get to the point they know them all after 5 minutes. So again, we'll go ahead and pause the video for 5 minutes now. Okay, so in our packets, let's be on page 7. We're going to look at our first proof involving parallelograms. So I want to draw your attention to this little symbol. Because we will do parallelograms for so many things, for parallelograms and parallelograms only, we will use a little symbol rather than writing it out. Any other figures we see like rhombus, rectangle, trapezoid, we will write it out. Those ones don't come up as much, so we pick the parallelogram as the one to use the symbol for because it'll save us the most writing. So we would read that as parallelogram RSTW and parallelogram XYTZ. And that's what we're going to put in as our only given. So let's go ahead and do our statements, reasons, and givens. All right, being given a parallelogram in a proof is huge because there's so many things that parallelogram implies. The last one on our card, parallelogram implies consecutive angle supplementary, rarely shows up in proofs. Again, we use that property mainly in algebraic problems. So we want to focus on the other four. In our pictures here, we don't have diagonals. So we would rule out parallelogram implies diagonals bisect each other. So we want to think which of our other three, parallelogram implies opposite sides congruent, parallelogram implies opposite sides parallel, and parallelogram implies opposite angles congruent. Which of those three could eventually help us get to what we want? Well, because R and X are angles, probably want to work with parallelogram implies opposite angles congruent. So let's do that reason next. So all we do, instead of writing out the word parallelogram, we draw our parallelogram symbol, and then implies opposites, and we can abbreviate that with OPP, angles congruent. Now we're going to want to involve R. R is in the big parallelogram. R is opposite angle T. So in our statement, let's do angle R congruent to angle T, comma. X is in that smaller parallelogram, XYTZ. So let's use X being congruent to its opposite angle, which is angle T. So we'll do angle X congruent to angle T. And we can put them all in the same step because the reason they're true is the same reason. Parallelogram implies opposite angles congruent. Now when we mark them, we've got separate pairs of things, so we got to use separate arcs. So we'll use one arc for R and T, and then let's use two arcs for X and T. Angle T got marked up two different ways, so there should be a bell going off in our heads telling us what we should do next. Turn to the people in your group and tell them what we should do for our next reason. I may not be in the room, but I hopefully heard a couple people say transitive property. So we have R congruent to T, X is congruent to T, so our conclusion from that now is angle R is congruent to angle X. On our original card, we had two things written as ifs and then a then. We don't need to write all three of those as our statement. The other two are already in our proof. It's just our conclusion that we're writing for the transitive property. Angle R congruent to angle X, and we proved what we wanted to prove. All right, let's go to our next one. Your statements, reasons, and givens. When you do that given, note you can use your picture symbol for parallelogram. You don't have to write out the whole word. So, of our 5 parallelogram things that it implies, remember, proofs rarely going to use parallelogram implies consecutive angles supplementary. So we want to think of our other 4 because we do have diagonals here. We eventually want DE congruent to BE. DE and BE are parts of our diagonal, so that's going to guide us as to which one to use. We'll want to do parallelogram implies diagonals bisect each other. So over on the left, we just want to say which things bisect each other. So we'll name the diagonals. We've got DB and AC bisect each other. So from this we have bisects. It doesn't talk about angles at all, so this should be segment bisector. Implies midpoint. They're crossing at E, so E is the midpoint of, and because they bisect each other, we can say it's the midpoint of both of them. So of DB and AC. Automatically next, we'll do midpoint. It implies 2 congruent segments. Now, we should be able to get 2 sets of congruent segments because E is the midpoint of both DB and AC, but in reality, we only need one of them. We only need DE congruent to BE. So for this particular proof, I'm just going to do the DE congruent to BE. But say we were trying to get some triangles congruent, then we would want to do both of the sets. Okay, we have them available because E is the midpoint of both, but we only wanted to prove DE congruent to BE, so I'm just going to write that one in this case. All right, going to the next page to number 3, we'll do our statements, reasons, and givens. Again, when you do your statement, you can use the parallelogram little picture symbol. So our 4 parallelogram reasons that we will see in proofs. Parallelogram implies opposite sides congruent. Parallelogram implies opposite sides parallel. Parallelogram implies opposite angles congruent. Parallelogram implies diagonals bisect each other. We want to see what one of those is going to lead us to angles 1 and 2 being congruent. Well, one thing I want to point out, when we say opposite angles congruent, that would mean the whole entire angle, not parts of them. So because 1 and 2 are only parts of them, probably not going to use the opposite angles congruent. What we want to recognize is that 1 and 2 are the angles of a zigzag. So we can get the angles of a zigzag congruent if we have parallel lines. But we can get parallel lines because we have a parallelogram. So that's going to guide us that we're going to want to use parallelogram implies opposite sides parallel. Now, we can get two pairs of opposite sides parallel, but for what we need, we just need the ones that are going to be part of our zigzag. So the only ones we really care about for this particular proof is that DC is parallel to AB. But again, you could get both sets parallel if you felt you needed them. From last unit, we can now use that parallel lines implies congruent alternate interior angles. And the angles of our zigzag are just 1 and 2 there. So we can say angle 1 congruent to angle 2, and we're done with this proof. One last proof we're going to look at. Go ahead, do your statements, reasons, and givens. All right, of our 4 main parallelogram reasons that are used in proofs, because again, we rarely see parallelogram implies consecutive angles supplementary in a proof. That's usually from algebraic problems we use that one. Of our 4 main ones, we do not have diagonals in this picture, so we rule out that one. So we want to use either parallelogram implies opposite sides parallel, parallelogram implies opposite sides congruent, or parallelogram implies opposite angles congruent. Looking at our proof statement, we want to get AB and FE congruent to each other. So that should hopefully lead us to think that we want to use parallelogram implies opposite sides congruent. So in that bigger parallelogram there's 2 sets of opposite sides congruent we can get. But we probably want to focus on the one with AB. So we can say that AB is congruent to its opposite side in that one, which is CD. And then let's do comma. In our other parallelogram, there's 2 sets of congruent sides we could get if we wanted. But let's focus on the one that has FE. FE is opposite of CD as well. So we can say FE is congruent to CD. We're going to mark those up in our picture with a different number of marks. I'll put 1 mark on those first 2, 2 marks on the second 2. Do you all hear a ringing in your ears? Hopefully you should. It should be a bell going off in your head by the fact that CD got marked up twice. That should be telling us what should happen next. If CD got marked up twice, we should do the transitive property. AB was congruent to CD, FE was congruent to CD. So our conclusion, we can say that AB is congruent to FE. That's it for today's lesson. Any time left in the period, you can get started on the homework or work on your problem set if you haven't completed that yet. Have a great rest of your day.